All right, in this video, we're going to talk about how to solve systems of equations where there's 3 equations and 3 variables. And I want to first of all start off by labeling each of these. So I'm going to call this top equation, equation 1, this middle one, equation 2, and this bottom one, equation 3. And that's just going to make it a little bit easier for you to be able to tell which equation I'm talking about throughout the video. And so when we're solving systems of equations, first of all, we need to make sure that all of the equations are written in standard form. And that means that all of the letters, right, all of these variables are on the left side of the equation, and then we've got the constant terms that are on the right side of the equation. So we're going to start this out by trying to eliminate one of the variables looking at 2 of the equations. Now it doesn't matter which one I start off eliminating. I can either eliminate the x's, the y's, or the z's. It's totally your preference and what looks easiest for you to do. So I'm going to choose to start with equation 2 and equation 3. All right, so equation 2 says 5x minus y plus 2z equals 3. And equation 3 is x plus 2y minus z equals negative 2. And I'm trying to eliminate the y's. It's the one I just decided because it looked the easiest for me to do on this. And so that means that I would want to take my equation 2 and multiply it by 2, because I'm thinking to myself, what do I need to multiply equation 2 by so that when I add it to equation 3, the y variable will eliminate, right? And so I can see when I distribute this 2 through to everybody, including that 3 over here, I'm going to end up with 10x minus 2y plus 4z equals 6. And so I'm going to add these together. And when I do that, I notice that my y variable eliminates, was what I was trying to do. So that is good that that's what happened. And so left, I've got x plus 10x is 11x, and then negative z plus 4z is a positive 3z, and that's going to equal 4. And then again, I'm going to name this equation, right? We already have equation 1, 2, and 3, so this new equation that I made by combining 2 and 3 together, I'm going to call equation 4. All right, now I need to eliminate the same variable, right? So I need to eliminate y's again, but using a different pair of equations. So I'm going to use equation 1 and equation 2 this time. Remember last time I used 2 and 3, so now I'm going to use 1 and 3. So let me write these down over here. So equation 1, 3x plus 4y minus 3z equals 4. And equation 2, 5x minus y plus 2z equals 3. And so in this one, again, if I'm trying to get my y's to eliminate, because I have to eliminate the same variable that I did the first go around, and so that means I need to this time multiply my equation 2 by 4. Right? And again, I'm going to distribute that through to everybody in that equation. And so that's going to give me 20x minus 4y plus 8z equals 12. Right? And I'm just going to put a little line through this now that I've already multiplied that through, because I'm really adding this top equation with this bottom equation, right? And so when I do that, I come up with 23 x. All right, I see that my y's eliminate. 4y minus 4y, right, is just makes it 0 out. It's eliminated. And then my z's, I get plus 5z equals 16. Okay, and again, I made a new equation by adding 1 and 2 together, so this time I'm going to call this equation 5. All right, so now I'm going to look at my equation 4 and equation 5 and notice that I have the same variables in there. I've got x's and I've got z's. All right, and so now I can go ahead and do this process again and eliminate either the x's or the z's. And so I'm going to write 4 and 5 together, one on top of each other here, so we can kind of see. So equation 4 is 11x plus 3z equals 4, and equation 5 is 23x plus 5z equals 16. So on this one, I'm going to have to multiply both equations by something in order to get the variable to eliminate. And I'm going to try and eliminate the z's this time. All right, and so to do that, I'm going to have to take my top equation and I'm going to multiply it by a negative 5. Negative 5 times 3z would give me negative 15z. And so that means my bottom equation, I need to multiply by a positive 3, because 3 times 5z gives me 15z. So I'd have a negative 15z and a positive 15z. And then when I add those together, those would eliminate. All right, so let me rewrite those out after I multiply those numbers through. Let me put them down here. So I've got negative 55x minus 15z equals negative 20. And now we need to multiply the 3 through on the other one. And that's going to give me 69x, right, plus 15z equals 48. Okay. And then again, I'm going to add these together, and when I do that, my z's eliminate, and I'm left with over here the negative 55 plus 69 is going to give me a positive 14x, and that's going to equal negative 20 minus, or negative 20 plus 48 is going to give me 28. And then to solve for x, let's divide by 14. So x equals positive 2. So I came up with one of my solutions, but remember, I've got to write my answer as an ordered triple. And remember that it just goes in alphabetical order. So my x goes first, then my y, and then my z. So I just found my x, right? So I found part of my answer. That's my x coordinate there. All right, now I still need to go find y and z. And so to find y or z, the next thing that I want to do, and would be easiest to do, is I'm going to take my answer that I came up with, my x equals 2, and I'm going to substitute that in to either equation 4 or equation 5. And it looks like equation 4 has smaller numbers, so I'm going to choose to use that one. But again, it wouldn't matter which one you used. Okay, but I'm going to put that 2 there in place of x. Okay, so when I do that, I get 11 times 2 plus 3z equals 4. So I got 22 plus 3z equals 4. Let's subtract the 22 over, because I'm trying to solve for z. So that gives me 3z equals negative 18. So z must equal negative 6. All right, so I came up with another solution. All right, I found out that my z is -6. So I'm going to go ahead and put that in up here. Whoops, I'm going to put that in black. So -6. And now I'm just left to find my y. So since I know my x, I know my z, I can come back to one of the original equations and substitute 2 in place of x, -6 in place of z, and then I'll have a y that I can solve for. So maybe I'll just choose, it doesn't matter whether I use 1, 2, or 3, I'll go ahead and use equation 2 on this. So I'm going to take my x equals 2, all right, and I'm going to put that in place of my x here, and I'll take my z equals -6, and I'll put that in place of z here. All right, so let me write down underneath here what I have. So I'd have 5. In place of x, I'm going to put my 2 minus y. All right, y is the one I don't know yet, plus 2 times z. Z is -6, so times a -6 equals 3. All right, so let's simplify up here. 5 times 2 is 10 minus y. 2 times -6 is -12 equals 3. So 10 minus 12, right, if I get my like terms together, it's going to give me a -2 minus y equals 3. Let's add the 2 over. So I get -y equals 5. And if I divide both sides by -1, I get y equals -5. And so there is my last solution there, my last part of my solution, y coordinate. Okay. I hope you can see that this can be a little fun game. I know it can be a little bit confusing when you first start off, but as you get used to it, you're like, okay, I just need to eliminate these, eliminate that. How can I do this? Substitute this back in. All right, so try and think of it as a game and try and have some fun with it.